All right, hello, welcome back. So in this video, I'm going to cover basically what we've been covering before, but I'm going to show you how to calculate some of these time value of money problems using the functions in Excel. In this video, we're going to start off with the future value function. Okay, so we're going to look at four problems. Two are lump sum problems and two are annuity problems. Okay, and we're going to calculate the future value in each of those problems. So let's take a look at this first one. Your mother just deposited $900 into a savings account at a bank that pays an annual interest rate of 7.515%. Suppose your mother decided to keep her money in the savings account for 3 years. How much money will she be withdrawing from the savings account after 3 years have passed? Okay, so this is a lump sum formula. She's going to ignore that, deposit $900 into the account today. She's going to earn a 7.515% interest rate. And we want to know how, after 3 years, how much money she'll have. Okay, so let's go over to our Excel sheet. And I'm using Excel, but all these functions are also work in Google Sheets. So if you don't have Excel, you can still use Google Sheets. To start off, this is problem one. We'll put an equal sign, and then we'll type FV, and then we'll do Shift 9 to open a parentheses. And you can see the function, or rather this is a function, and each one of these little letters is the variable, right? The input into our function. So rate is the interest rate. That needs to be put in decimal form. In PER or INPER is the number of periods. PMT is the payment. PV is the present value, and then type is type is a designation for whether or not we're looking at an ordinary annuity or an annuity due. I'll come back to type in a second. Type is not relevant for this problem because this is a lump sum problem, not an annuity problem. Okay, so for rate, the rate is 7.515%, so that's going to be 0.07515, and then we'll put a comma. The comma denotes we're moving over to a new input. INPER, which is the number of periods, and that's 3, and then do a comma. Right, payment, well, this is a lump sum formula, so there's no payment, so we just put a 0. Then you do comma, and now we have the present value. Well, the present value is 900, but because that's being deposited into this savings account, that's really a cash outflow to us. So we should put a negative 900, and then we do comma, and type isn't relevant here, so we can just close. We don't actually have to put anything for type in this case, so we can just close the parentheses. So Shift 0, and there it is. Right, we see that after 3 years, her $900 should turn into $1,118.54. Okay. All right. So that's the FV function for a lump sum. All right. Let's look at number 2 now. Okay. All right. So number 2. Suppose your grandfather, starting today, deposits $800 each year into a savings account that pays an annual interest rate of 5.949% for 4 years. I don't know why I put a question mark there. I'm sorry about that. How much money will he have accumulated by the beginning of the 4th year? Okay, so this, as we can see, is an annuity, and because we're starting today, it's an annuity due, right? And you can see from the timeline, each payment, the first payment starts at year 0, not at year 1, right? So we need to find the future value of this annuity due, right? So he's going to be depositing $800 in this account, earning this interest rate up here each year on each of those payments. Okay, and we want to know how much he'll have by the beginning of the 4th year. Okay, so in this case, we'll go to 2. Once again, we'll put equal sign, FV, and then Shift 9 to open a parentheses. And then our interest rate, well, that's 5.949%, or we have to put it in decimal form, so it's 0.05949, and then we do a comma to move over to the next input. INPER, well, it's 4 years, so we just put a 4, comma. PMT, because this is annuity, that's going to be our $800 payment that your grandfather makes each year. But again, because it's a cash outflow into the savings account, it should be a negative 800, right? And then we do a comma. Now in this case we need to put the PV, but there is no PV because it's an annuity, so we'll just put 0. And then finally for type, Because this is an annuity due, we need to put a 1, right? So we'll put a 1, and then we'll close the parentheses, and then press enter. And so by the beginning of the 4th year, that annuity will have amassed $3,705.08. Okay? All right. Now let's move to problem 3, all right? Oops. Now, suppose your father deposits $9,000 into a savings account that pays an annual interest rate of 5.043%, and he leaves it there for 43 years. How much money will he have in savings after 43 years? So, as you can see just from the timeline, this is a lump sum problem, not an annuity problem. So this is the present value, and we want to find the future value. So we go back to 3, so we put equal sign, FV, open a parentheses. Our rate is 5.043%, or because it has to be in decimal form, 0.05043, comma. Number of periods, well, there's 43 years, he's going to leave it in there. PMT, this is a lump sum problem, not an annuity problem, so we need to put just 0. PV, and we'll put negative 9,000 because, of course, that 9,000 is a cash outflow into the savings account. And then comma, we don't have a type. That's not relevant here because it's a lump sum problem. And then we'll close the parentheses, press enter, and we'll see that 9,000 after 43 years will have turned into $74,649.78. So compound interest is really taking full effect there. All right. Last one. Let's move on to problem 4. It looks like we have another annuity problem. So starting 1 year from today, your grandmother will deposit $1,200 each year into a savings account that pays an annual interest rate of 4.397%. How much money will your grandmother have amassed by the end of the 27th year from today? Now, just going back for a second, and because this is also relevant for this problem, but notice with 3, remember we had 9,000. Now notice I didn't put the comma between the 9 and the 0 that denotes thousands, right? You don't want to do that when you're using these functions, because a comma in this sense means that it's a new input, right? So you don't ever want to, when you have like thousands or hundreds of thousands or even millions, you just want to put the numbers in, the digits in, but you don't want to put those, divider commas, okay? So for instance, if I did this, I would get something like this. You've entered too many arguments, right? It would give you something wrong, right? Or even if I didn't put that, it would give me something like that, something ridiculous, right? So what you need, so you can't ever do that. You need to just put the numbers in, just put the digits in, don't put the divider comma. So that's also relevant here. So getting back to this problem, notice your grandmother's going to deposit $1,200 each year into this account for 27 years. Notice because it starts 1 year from today, right? That indicates this is an ordinary annuity. So notice that the first cash flow happens not at year 0, but at year 1. Okay, and your grandma's going to be earning this interest rate. All right, so let's go back. We'll put equal sign, FV, shift 9 to open a parentheses. The interest rate is 4.397%. So in decimal form, that's 0.04397. Then we'll put a comma to do a new input. Number of periods, that is 27 years, comma. Payment, that's 1,200. So we need to put a negative 1200. It's a negative because it's an outflow. Okay. It's an outflow. Or it's a deposit into a savings account, so it's an outflow. Then comma, it's an annuity, so there's no present value, so we should put 0. And then type, this is an ordinary annuity, so we just need to put 0, right? So when we have an ordinary annuity, we put it in a 0 for type. When we have an annuity due, we put in a 1. So shift 0 to close the parentheses, and what we'll see is that after the 27th year, by the end of the 27th year, your grandmother will have amassed $59,925.69. Okay? All right, so that'll do it for this one. In the next video, I'm going to look at the PV function, the Excel function for present value. All right, so that'll do it. Have a good one. Bye.